we'll do some problems now itself. Okay, so now the simple topic though konja earlier vittirren, you just study for your test. Okay, 3 o'clock and again you have to join. Okay, don't miss it. So 11th we have to start somehow. So okay, so now the full lag 12th complete panna 11th complete panna, it will be lag again. So parallel we have to move. Right. So last classes we are discussing about your 1 minute. Yeah. Okay. So last topic we have discussed about your electromagnetic induction, and the electromagnetic induction we have seen your loss of electromagnetic induction. At the first law we have seen the Faraday's laws. Correct? Faraday's laws வந்து ரெண்டு laws நம்ம டிஸ்கஸ் பண்ணிருக்கோம். First law வந்து அதோட magnitude, second law வந்து அதோட relation. So magnitude E is equal to your d5 by dt. And electromagnetic induction law, second law வந்து Lenz law. So Lenz law பத்தி நம்ம டிஸ்கஸ் பண்ணிருக்கோம். Lenz law is nothing but your direction. So Faraday's law indicate your magnitude and சொல்லும்போது Lenz law indicates your direction. Okay, இது நம்ம டிஸ்கஸ் பண்ணிருக்கோம். And after that we have seen your methods to induce EMF. Methods to induce EMF. இதுல வந்து there are three methods are there. First one is your changing magnetic field. Changing magnetic field. Second one is your changing orientation. That is your area. Change in area. And இதுதான் motional EMF சொல்லிட்டு நம்ம டிஸ்கஸ் பண்ணிருக்கோம். And third case வந்து change in orientation coil. Change in orientation coil. Okay, so these are the three relations which we have discussed in last class. EMF வந்து எப்படி induce பண்றோம். In the case வந்து what is the equation for motion EMF? Relation for motion EMF? Relation for motion EMF?
I is equal to BLV.
I is equal to BLV.
E is equal to BLV, sir.
Electric field. இது E na என்னதுமா? Electric field. EMF. Okay, good. What is EMF?
Voltage, potential difference.
Potential difference. இது AC or DC? EMF.
DC.
AC or DC? I told you EMF is nothing but a cell and சொல்லிருக்கேன். கரெக்ட்டா? So EMF voltage is nothing but a cell. It is your DC supply. Okay, and the current control பண்ணனும்னா it has its own internal resistance ன்னு சொல்லிருக்கேன். This is smaller. நம்ம வந்து current electricity டிஸ்கஸ் பண்ணிருக்கோம் இதெல்லாம். கரெக்ட்டா? And motion EMF ல வந்து what is the current relation? அதுல வந்து நம்ம டிஸ்கஸ் பண்ணிருக்கோம். motion EMF with respect to your Faraday's laws ன்னு சொல்லிட்டு ஒரு ரிலேஷன் டிஸ்கஸ் பண்ணிருக்கோம். Same motion EMF by using your Lenz law ன்னு சொல்லிட்டு நம்ம டிஸ்கஸ் பண்ணிருக்கோம். என்ன பேரு? Faraday's law relation இருக்கு, Lenz law relation இருக்கு. Okay. So what is the current for your Lenz law? Lenz law based பண்ணி we have extracted it. அதுல வந்து நம்ம current பார்த்திருக்கோம் relation and EMF பார்த்திருக்கோம் and as well as you have seen the power also if you remember it. So what is the EMF? EMF is equal to BLV, correct? So when you are discussing about the current carrying conductor ன்னு சொல்லும்போது it has its own internal resistance அவ்வளவுதான். So I is equal to is a BLV divided by R. This is your current. Power ன்னு சொல்லும்போது P is equal to I square R. நான் இருக்க இந்த ரிலேஷன் ஆல்ரெடி டிஸ்கஸ் பண்ணிருந்தோம் இது. And the heat dissipated ன்னு சொல்லும்போது I'll take this H is equal to I square RT. Okay, so these are few relations. And after that நம்ம வந்து circular motionல நம்ம டிஸ்கஸ் பண்ணிருக்கோம். Circular motionல when you are placing a conductor inside the magnetic field, so when you are making this conductor to move inside the circular motion, what will happen? அதோட EMF வந்து நம்ம எக்ஸ்ட்ராக்ட் பண்ணிருக்கோம். EMF E is equal to half. What is the relation? அப்ப இருக்க இந்த ரிலேஷன் நம்ம எக்ஸ்ட்ராக்ட் பண்ணிருக்கோம் இது for the circular. நீங்க தான் வந்து எடுத்து புக் படிக்கிறீங்க நீங்க. half B L square omega ன்னு சொல்லிட்டு நம்ம டிஸ்கஸ் பண்ணிருக்கோம் for the circular motion of a conductor. Okay, இதுல நம்ம வந்து current டிஸ்கஸ் பண்ணிருக்கோம், இதுல வந்து power டிஸ்கஸ் பண்ணிருக்கோம். Remember it. Okay, so next case is your eddy currents. And before going to the eddy currents, change in orientation. Change in orientation சொல்லும்போது அந்த coil வந்து when it is rotating circular motion continuously rotate ஆகும்போது we have extracted the relation. அதே relation வந்து we will see again in AC generator ன்னு சொல்லிருக்கோம். The relation is E is equal to E naught sin omega t. E is equal to E naught sin omega t ன்னு சொல்லிட்டு ஒரு ரிலேஷன் நம்ம டிஸ்கஸ் பண்ணிருக்கோம். So let's see. So and after that eddy currents ன்னு சொல்லிட்டு I told you that it is one of the losses in your transformers. Today we're going to discuss about the eddy currents, how to rectify the eddy currents, and what are the applications of eddy currents. So we'll see the headings and detail எதுவுமே வேணாம், இது it will take time. And after that we'll see the self induction, mutual induction. Today these are the contents which we are going to discuss. So first of all we'll try to understand your eddy current. Eddy current. So I'll give a point, so then we'll discuss eddy current. So eddy currents are the currents induced in solid metallic masses when the magnetic flux threading through them changes. Okay. Eddy currents are the current induced in solid metallic masses when the magnetic flux threading through them changes. Remember it. So in this case, remember here is only one of the losses on solar transformer. Okay. So let's see, we'll try to understand in detail about it. So eddy currents, now just remember eddy currents, these are nothing but your circular currents which are formed inside the solid structured conductors. So let's see, we'll try to understand it. Okay. So here I'm just taking an example. Based on it. So here what I'll do, I'll take a magnet, assume this is your north pole, and assume this is your south pole. So random magnets I'm just placing like this. Okay, the magnetic field lines are traveling from north towards the south. So I'll take this one as north pole and I'll take this one as south pole. So field lines will be traveling from north towards the south, the direction. Everything is good. So in this magnetic field, I'm just placing a solid metallic structure, solid metallic plate on the I'll place it in between your magnetic field. When I place it in between your magnetic field, the field lines will cut agadu. Remember, when you're placing this conductor inside the magnetic field, it won't cut the magnetic field lines. Magnetic field lines cut panada and EMF on the induce agum solirkum. I'm just placing here. So for the current or the EMF to be induced within the conductor, what I have to do, the magnetic field lines should be cut. I'm just connecting this conductor so through a point, so on the top, like a pendulum madri na connect pannirken. I'll make this conductor to move to and fro motion. Make this conductor to move to and fro motion. When I'm moving it, remember, when I'm making it to move to and fro motion, what will happen? The magnetic field lines will be cut. When the magnetic field lines are cut, what will happen? There is an EMF induced within the conductor. EMF induced within the conductor. Because of the EMF induced within the conductor, so what will happen? Current will be flowing through the conductor. But this is the written path and it is a closed path. Okay, whatever the things is there, it is a closed path. So it is a full solid structured conductor. Solid conductor. Okay, so solid conductor on Solombo, so it will be like this. So it will be like this, a solid conductor. So full solid conductor. Okay, so in this solid conductor, so I'm just placing in the magnetic field. Okay, so in the solid conductor, so here when we are making it to move continuously again and again within the magnetic field, what will happen? It will try to cut the magnetic field and the EMF on the induce agum. But EMF induce agradhu, remember EMF induce agradhu, so there is no path to travel the current from this conductor. So there is no continuous path. So whatever the wire we are connecting here, I'm just taking this wire as your non-metal and solla illana or thread and solla. This is your non-metal. So through this non-metal only I'm moving this conductor inside the magnetic field. So the current induce agum and there is no written path. Whatever the current it is induced, so this current will be circulating in circular form. So it will be forming in circles. Remember, it will be forming in circles. So these circles, these circular currents, we call it as eddy currents. These call it as eddy currents. So remember, in the continuous move the current on the induced side, this current will be in the circular format and it will try to oppose the cause itself. Now we are going to discuss about the lens. So first on the number Faraday's law பார்த்துக்கோம், there is a current induced ஆயிருக்குன்னு சொல்லிருக்கோம் from the lens law. That means what are the source? This magnetic field is nothing but your source. Because of the source, EMF வந்து induce ஆயிருக்கு. Because of the EMF, current வந்து induce ஆயிருக்கு. Current வந்து induce ஆயிருக்கு. Because of the current, what will happen? It will try to oppose the source itself. It will try to oppose the source itself. The source oppose பண்ணிட்டு இருக்குன்னா, it will try to stop. So இதோட motion வந்து it will try to stop. Rest condition க்கு வந்துரும். That means there is no relative motion. It will try to stop there itself. So that means it will try to oppose the flow of path. Okay, so this is nothing but your eddy currents. Eddy currentsனால வந்து நிறைய டிஸ்அட்வான்டேஜஸ் இருக்கு. அண்ட் இதுல எப்படி இருக்குன்னா அதோட மூவ்மெண்ட் ரிலேட்டிவ் மோஷன் ஸ்டாப் பண்ணிடுது. Okay, to avoid this eddy currents, we are doing the laminations. Lamination சென்ஸ் எப்படின்னா, சப்போஸ் இந்த சாலிட் மெட்டல் கண்டக்டர் இருக்கு, நான் என்ன பண்றேன்னா இது வந்து thin sheets கட் பண்றேன். What are the conductor I am discussing here? இந்த கண்டக்டர் வந்து நான் thin sheets ஸ்லைஸ் பண்ணிட்டு, so thin sheets நான் கட் பண்ணிட்டு again I am going to join it. Okay, so thin sheets cut பண்ணதுக்கு அப்புறமா again I'm going to join it. Join பண்றது எப்படி இருக்குன்னா, in between we are using a insulation tape and யூஸ் பண்ணலாம், insulation papers யூஸ் பண்ணிக்கலாம், even on the oil யூஸ் பண்ணலாம் as an insulator. So like this we are going to cut it in slice. நீங்க பாக்கும்போது ஓபனா பண்ணனும்னா நீங்க புக் இருக்கு உங்க புக். So book நீங்க side views பாக்கும்போது, so the papers are the sheets. So the sheet, whatever the sheets are there, so we are cutting like this and we are going to join it, combine. So we call this one as lamination. So laminations பண்ணும்போது what are the eddy currents are forming, ஒரு ஷீட்க்கு வந்து eddy currents form ஆகுறது, it won't link to the other current. Okay, so that's why so eddy currents can be reduced. So by making the laminations, eddy currents can be reduced. It is one of your major laws in your transfer. So eddy currents reduction reduced by laminations. Okay, and one laminated sheet is not linked to the other laminated sheet. These two are separated by your insulation paper, insulated paper based பண்ணிருக்கும், or we can use oil also one of the insulator. Okay, so like this you can say, just remember it. Okay, so just try to understand this. And what are the material I'm discussing here? In the material I take it as copper material, copper conductor, or you can say copper plate. Okay, these are your eddy currents. It is simple damping structure. It continuously on the move ஆயிட்டே இருக்கும். Continuously move பண்ணும்போது current வந்து induce ஆயிட்டு இருக்கு, அந்த current வந்து circular formatல இருக்கும் because there is no return path. So அந்த currentனால வந்து என்ன ஆயிட்டு இருக்கு, அந்த source-னை oppose பண்ணிட்டு இருக்கு by using your lens. Okay, so this is your eddy currents. Just remove. And இதோட applications ன்னு சொல்லும்போது there are so many applications are there. So applications ன்னு சொல்லும்போது, so we'll use this in induction furnace. Induction furnace.
The deadbeat galvanometer.
Right man, correct man. Good. So இங்க வந்து induction furnace இருக்கு and electromagnetic damping இருக்கு, that is your galvanometer. So continuously on the fluctuate ஆயிட்டே இருக்கும் இது. So we call it as electromagnetic damping. Electromagnetic damping. Third cases ல வந்து electric brakes. Electric brakes ன்னு சொல்லும்போது நம்ம ரயில்வே ட்ரெயின்ஸ்ல வந்து நம்ம யூஸ் பண்றோம் இது. Okay, so trains use பண்ணிட்டு இருக்கோம். So by using the eddy currents only we are using. And one more thing, speedometers ல நம்ம யூஸ் பண்றோம்.
Speedometer. Okay.
Speedometers ல நம்ம யூஸ் பண்றோம். These are your few things. And after that I'll use this in motor also, induction motor. Okay, and as well as electromagnetic shielding also. There are so many applications. Electromagnetic shielding. Electromagnetic shielding and even energy meters and சொல்லிட்டு ஒரு ரிலேஷன்ஸ் இருக்கு. நம்ம வந்து எனர்ஜி what are the energies we are using in our households, அதை மெஷர் பண்றதுக்கு energy meters. Under this energy meters also these relations will be used. Energy meters. Okay, so just remember it. Just a concept. Okay, so the applications are ரொம்ப important. I'll share you the material, you can go through.
Over, sir.
Okay,
Mm.
so let's see next one. Next one. So eddy currents is our application, so let's just go through it. If you have any doubts, you can ask. Okay, so let's see next one. So next one, we'll discuss about your self-induction and as well as your mutual induction. Let's see. So self-induction first. Self-induction. Self-induction. So I'll write the point here. It is the phenomenon of production of induced EMF in a coil when a changing current passes through it. So self-induction சொல்லும்போது நம்ம பாடஸ்ல ஃபர்ஸ்ட் கேஸ்ல நம்ம டிஸ்கஸ் பண்ணோம். தட் இஸ் யுவர் ஃபர்ஸ்ட் எக்ஸ்பெரிமெண்ட் என்னன்னா சிங்கிள் காயில் எடுத்துட்டு கரண்ட் ஃப்ளோ பண்ணும்போது எப்படி இருக்கும் அண்ட் மேக்னெட்டிக் ஃபீல்ட் வந்து அங்கே கண்டினியூஸா வந்து சேஞ்ச் பண்ணும்போது அதோட கரண்ட் டைரக்ஷன் எப்படி இருக்கும் and those things we have discussed. Same thing, self-induction. So let's see, we'll try to understand here. So what I'll do, I'll take a coil. The coil எடுத்துக்கிறேன். So I'll assume this is your coil. And in the coil, what I'll do, I'll connect a battery. And in the battery I'll use a switch. This is your switch. And when the switch open, this is your open circuit. When the switch closes, this is your close circuit. Now what I'll do, now the switch close panna. So it is your closing switch. Okay, so it is your battery. And in the battery, through what will happen, the current is flowing through it. So this current is nothing but your battery current. Okay, so here if you see that, so on the point it is the phenomenon of production of induced EMF in a coil when the changing current passes through it. So when the changing current passes through it. Let's see. So here current flow in the case of here the current is flowing through this inductor. Current flow there will be having some flux. So or flux induce. So because of the flux there is an EMF across this inductor. Because of the EMF will be induced across this inductor, current flow. And the current will be your induced current. That current will be flowing. That current will be flowing in opposite direction. So when the switch is closing, induced current will be flowing in opposite direction. Remember, it is your induced current because of the flux through this inductor. Induced current direction. So when the switch is closing and சொல்லும்போது இதோட current எப்படி form ஆயிட்டுனா it will be flowing from coil. Okay, so magnetic flux from 0 to maximum value. So current flow ஆயிட்டு from 0 to maximum. Same thing. So இதுல என்ன ஆயிட்டு இருக்குன்னா magnetic flux also changing from 0 to maximum. So I'll write here. As a switch closes, current increases from 0 to maximum. Same thing here, when the switch is closed, current flow aayittu flux induce aayittu. So here magnetic flux also changes. Magnetic flux increases from your 0 to maximum. Okay. So inga enna aayittu switch na close pannittu induced current in opposite direction. Remember. Same thing. So what I'll do, I'll take the same coil. Okay, so adhe madri I'm just connecting a battery. This is your battery, and I'm using a switch here. And this is your open circuit. And on the switch na open pannirken. This is your open circuit, and this is nothing but your battery. And if I enna pandrena, earlier the switch is closing. Upon the current flow direction is 0 and the maximum. Now here what I'll do, I'll open the switch. Sudden open. So I can say sudden open. So opening the switch. When I open the switch, what will happen? Current flow. So there is a current. So Anna, because of the flux and because of the change in current, what will happen? Flux on the induced ஆயிட்டு because of the flux induced, there is an EMF. Because of the EMF, current flow ஆயிட்டு that current will be your induced current. So இப்போ இதுல flow ஆகுற current induced current it will be in opposite direction, okay, to the earlier case, and same direction to the current. It is your induced current. Remember, this is your first case and this is your second case. இதுல when the switch opens, when the switch opens, okay, current decreases, current decreases from maximum to zero. ஏன்னா வந்து அது open பண்ணிட்டு இருக்கேன், from maximum to zero. Same thing for magnetic flux. Magnetic flux from maximum to zero. Remember these cases. So by comparing these two relations, we can say that flux phi is directly proportional to your change in current. So flux phi is directly proportional to your current. So flux இருக்கிறதுனால current வந்து induce ஆயிட்டு இருக்கு, and current இருக்கிறதுனால அந்த battery current இருக்கிறதுனால என்ன ஆயிட்டு இருக்கு, flux வந்து generate ஆயிருக்கு. Both are proportional to each other. So when both are proportional to each other, when you remove it, what will happen? There will be proportional constant. That proportional constant we call it as L. So L we call it as self inductance. This L is a constant value. So we call it as self inductance. We call it as self inductance. Okay, self inductance சொல்றோம் because flux வந்து direct link ஆயிருக்கு. Or we can say simply inductance also. Simply inductance. Okay, so here in this case, okay, self inductance and சொல்லும், or else I can say this one as a coefficient of self induction. Coefficient of self induction. Coefficient of self induction. Okay, so here we know that EMF வந்து இதுல induce ஆயிட்டு இருக்குன்னு சொல்லிட்டு நம்ம டிஸ்கஸ் பண்ணிருக்கோம். Let's see the relation. So assume there is an EMF induced. So EMF E is equal to, we know that it is a minus a d phi by dt. EMF E is equal to minus d phi by dt. So flux phi is equal to your L into I. I'm going to substitute the relation. Minus d by dt of L into I. So L வந்து always constant ன்னு சொல்லுங்க. L நான் remove பண்றேன். It is a di by dt is your EMF. Okay. So now இதுல ஒரு சின்ன கேஸ் பார்க்கலாம். If so your current I is equal to your 1 amp. Current I is equal to 1 amp, then flux is equal to your inductance. The same thing, if di by dt is equal to 1 amp, so then EMF E is equal to minus your inductance. Okay, please take it.
Sir, sir, over, sir.
Okay, right. So we'll see next one. So இதுல வந்து இதோட யூனிட் பத்தி நம்ம டிஸ்கஸ் பண்ணோம். So the relation is
Self inductance தானே சார் ஹென்றி ஒரு யூனிட்.
செல்ஃப் இண்டக்டன்ஸ் தான் என்னமோ புரியல.
ஹென்றி.
ஹென்றி, எஸ் மா, குட் மா, கரெக்ட். ஹென்றி தான் யூனிட். பட் அது ஹென்றி எப்படி வருது, அது ரிலேஷன் எப்படின்னு சொல்லிட்டு. So here L is equal to your E divided by R. We can say EMF E is equal to your L into di by dt. Okay, 1 minute. Okay, so in this case, L is equal to, I can rewrite the relation as L is equal to E divided by di by dt. Okay, E divided by di by dt. So EMF E is nothing but your voltage, di by dt is nothing but your current per second. Current na ampere per second. So R, I can rewrite the relation as volt ampere inverse second. R, this is your Henry capital H. So you can rewrite the relation as volt ampere inverse second as well, or else you can write as Henry. Henry is your SI unit. Okay, right. So there are dimensions part. So you know about the dimensions, right? So can you able to find the dimensions for L inductance? Did you try? Yes, right. Over.
1 minute. Sir, ml square
Hmm.
t power minus 2 a power minus 2
ml square 3 power minus 2
a power minus 2.
a power minus. Yeah, correct. Good. Okay. Right. So next we'll discuss about this relations. One by one. Let's see that. Okay. Right. So next one, next heading. Self-inductance of a long solenoid. Self-inductance of a long solenoid. Self-inductance of a long solenoid. Okay, let's see the relations. So here what I'll do, I'll take a solenoid. Solenoid and solidity எப்படி சொல்றோம்னா அதோட length of the solenoid வந்து it should be greater than your radius of the solenoid. Let's see. So assuming I'm just taking a solenoid like this, and it is nothing but your inductor. Okay, so இதோட radius வந்து from the center, இதோட radius வந்து I'll take the radius as r. Okay, and இதோட length வந்து I'll take it as l. So நான் வந்து ஒரு coil வந்து எப்போ நான் வந்து solenoid னு சொல்றேன்னா, so the radius வந்து much smaller than length of the coil. Okay, so radius வந்து much smaller than the length of the coil. So then we can say it as a solenoid. I'm taking a solenoid long and it has its own length. So I'll take it as a number of turns. It has its own number of turns also. I'll take a small n. Small n is nothing but your number of turns per unit length. Number of turns per unit length. And if you want to find the number of turns, capital N, I'll consider this as number of turns. Number of turns. So let's see the relations. So here, when we allow the current passing through it, what will happen? It will try to convert that into your flux from your thumb rule based on magnetic field on the induced electric. So other directions, we already seen it, and we always seen the relation. Flux phi is directly proportional to your current here. Flux phi is directly proportional to your current. Okay. Now let's see. So when you are discussing the flux phi, Ampere circuit, discuss Ampere circuit, it is a closed integral B into dl is equal to mu naught times I. Okay, and if you want to find the number of turns on சொல்லும்போது so again அது நம்ம extract பண்ணது solenoid. So that is your solenoid ல பார்த்துக்கோம், toroid ல பார்த்துக்கோம். B is equal to mu naught times Ni ன்னு சொல்லிட்டு ஒரு relation பார்த்துக்கோம். நான் பேருக்கா இது? When we are discussing about the number of turns, so B is equal to mu naught Ni, where N is nothing but your number of turns per unit length. I'll take this one as first relation. And we know about the flux. Flux phi is equal to, so இது வந்து flux phi வந்து for each turn. Flux phi for each turn. When we are discussing about the each turn, so we know that flux phi is equal to B into your area, which is equal to B already தெரியும், which is a mu naught Ni into your area. Okay, I'll take this one as a second relation. And when we are discussing about the coil சொல்லும்போது it is nothing but your circular format. இதோட area is nothing but your pi r square. The radius is nothing but your r. I'll take the area is pi r square. So I'm going to substitute the relation here. So here in this case, when we are discussing the flux, the total flux. So let's see the total flux linked to the coil. So the total flux is equal to, remember, flux linked with each turn. Flux linked with each turn. Flux linked with each turn into your total number of turns. Into total number of turns. Number of turns. So each turn also the relation is mu naught small n I a into total number of turns is nothing but your capital N and solirican. So the relation between small n and capital N is like this. So small n is equal to number of turns per unit length. So capital N is equal to small n into n. So capital N is equal to small n into l. I'm going to substitute that relation. So it is a small n into n. So which is equal to, so mu naught n square I l into a. This is your total flux induced within this coil. எனக்கு வந்து flux தெரியும். And I'm going to compare this with respect to you. The relation flux is direct, phi is directly proportional to your current. That means the flux phi is equal to L into I, where L is nothing but your self-inductance and so on. So I'm going to compare. So I'll take this one as a fourth relation. I'll take this one as a third relation. Comparing third and fourth. Comparing third and fourth. When you do compare the relation, so here L is equal to, when you do compare, so L is equal to, the relation is mu naught n square L into A. Remember, L is equal to mu naught n square L into A. We got the self-inductance. Now, when we're discussing about the small n and the number of turns per unit length. So when I do substitute here, number of turns, so small n is equal to mu naught, it is a n square divided by L square into L into A. So LL will get cancelled. So the relation I can rewrite it as L is equal to mu naught n square A by N. Remember this one. This is your self-inductance process. Okay. Please take it. Whatever we are discussing here, this is in vacuum. Vacuum based on the number discuss. Please take it.
Over, sir.
Forma. So let's see. So next is. So இதில் வந்து we have seen the inductance. இது வந்து நான் medium. So that is your vacuum நான் discuss பண்றேன். Suppose when we are discussing about in any medium. Okay. So okay. So when you discuss about any medium, so அப்போ வந்து the relation mu r will be there. Okay. We call it as a relative permeability. Relative permeability. So let's see the relations. So in this case, A is equal to this mu naught n square. Okay, so it is A into L for number of turns per unit length. Other than the number of turns, L is equal to mu naught capital N square A divided by L. Okay, so in this case, number of turns, that is ஒரு medium பத்தி நான் டிஸ்கஸ் பண்ணும்போது ஏதாவது மீடியம்ல நான் இந்த கால் பிளேஸ் பண்ணும்போது ஸோ கரண்ட் ஃப்ளோ பண்ணும்போது what will happen, the relative permeability will be there. So that moment the relation will be it's a mu naught mu r small n square L into A, or I can write the relation as a mu naught mu r, it is the capital N square by L into A. Remember this. So here in this case, remember, so in the self-inductance, it is directly depends upon three things. So L depends upon three terms. Depends upon, so depends upon first one. So here number of turns on this. So whatever the self-inductance, it is directly proportional to your number of turns. So L is directly proportional to your number of turns. It is N square. Remember it. So larger the number of turns, the larger the self-inductance value. Number of turns is ಜಾಸ್ತಿ ಇರಬಹುದು, self-inductance value ಜಾಸ್ತಿ ಇರಬಹುದು. This is your first point. Second point, area of the conductor. So here, if the area of the conductor is larger, so what will happen? The self-inductance also larger. So L is directly proportional to your area. Third case, permeability. So here the permeability L is directly proportional to your permeability of the material. If the self-inductance of the solenoid increases mu times, so here it would your relative permeability. Suppose if you are discussing about your relative permeability, that is depends upon the material, it is directly proportional. So that means, so inductance is proportional or directly depends upon okay, permeability. Inductance directly proportional to your permeability. Depends upon the material. So that is your mu r. It will be a multiplication factor. So these are your dependencies. Please take it.
Sir, over, sir.
Okay, right now. So next one we'll discuss about the mutual inductance. For last topic.
Sir, RLC circuit in the chapter தானே sir வரும்.
Okay. So one second.
Okay.
One second.
Hmm.
right? So next one is your mutual induction. Next one is your mutual induction. Mutual induction. Let's see. So I'll give the point, then we'll discuss. So mutual induction, it is a phenomena of inducing. It is a phenomena of inducing EMF in the secondary coil, EMF in the secondary coil due to change in current in the primary, due to change in the current in the primary coil, and hence the change in magnetic flux, the change in magnetic flux in the secondary coil. Let's see, it is a phenomenon of inducing EMF in the secondary coil due to the change in current in the primary, and hence the change in flux in the secondary coil. So in this case, now on the primary coil, so we already discussed when we are discussing about the Faraday's laws. Adula on the first case, second case is we discuss experiments. So same thing here. So what I'll do, I'll take a coil. So I'm already discussed pannadha. So I'm just assuming a coil here. So this is your primary coil. So primary coil. So here for this primary coil, I'm adding a voltage to it. So voltage is connect பண்றேன். So இதுல வந்து current flow ஆயிருக்கு. Because of the current flowing through this coil, what will happen? The flux will be induced here. So the flux will be there. It is a single coil. So for this primary coil, I'm adding, I'm placing one more coil closer to it. Or inner coil and then I'm placing closer to it. When I'm placing the secondary coil closer to the primary coil, okay, so this is your secondary and this is your primary. So the primary coil's magnetic field is linking to the secondary coil, and there is an EMF induced within the conductor, and because of the EMF induced, what will happen? The current will be flowing through it, and it will be detected in your galvanometer. This is the number discussed. So because of the primary coil's flux linking to the secondary coil, so the flux link ஆனதுனால current வந்து induce ஆயிருக்கு. Okay, current வந்து induce ஆயிருக்கு. So when the current is induced within the coil, என்ன ஆயிருக்கு? இங்க வந்து galvanometerல deflection இருக்கு. So everything is good. So now let's see the relations here. So that means flux phi 2, that means the flux on the secondary induce due to your 1. So I'll take the relation as phi 2. Suppose அதே case தான். So here I'll take the relation as a primary towards the secondary. இதுக்கு vice versa இருக்கு. Secondary வந்து நான் voltage connect பண்றேன். Primaryல வந்து I'll connect the galvanometer. Primaryல I'll connect the galvanometer. Okay, so in this case, அப்போ என்ன ஆகும்னா flux என்ன ஆகும்? So secondary னாது primary க்கு link ஆகுறதுனால I'll take the relation as flux phi 1 2 ஆகும். Okay, so இது phi 2 1 phi 1 2. You can connect the voltage or the galvanometer either way. So primary to secondary, secondary to primary, vice versa we can do it. So if you see that current னால தான் flux வந்து induce ஆயிட்டு இருக்கு. Sorry, current னால தான் flux generate ஆயிருக்கு. அந்த flux னால again secondaryல current induce ஆயிருக்கு. So that means the flux phi 2 1 is directly proportional to the current I1. ஏன்னா வந்து current I1 னால தான் வந்து flux வந்து link ஆயிட்டு இருக்கு. The same thing, so flux phi 1 2 is directly proportional to your current I2. Flux phi 1 2 is directly proportional to your current. So இது வந்து first case, இது வந்து second case. Okay, இதுல வந்து primary வந்து galvanometer connect பண்ணிருக்கோம், secondary வந்து voltage. Okay, remember this relation. Now ரெண்டும் வந்து proportional to each other இருக்கு. நான் வந்து equate பண்ணும்போது என்ன ஆகும்? Flux phi 2 1 is equal to a mutual induction M into current I1. Here also flux phi 1 2 is directly proportional, that is your equal to your mutual induction into your I2. So there is a mutual inductance in between your primary coil to the secondary coil. Mutually it is connected to each other. Okay. Now in this case, M is nothing but your mutual inductance. M is your mutual inductance. Mutual inductance, other symbol on the M, other unit on the Henry. As we have discussed, the same unit the one. Same unit and as well as same dimensions also. Now you'll see the relations. So in this case, I'm going to find the EMF induced in the secondary. So secondary EMF I'll take this E2. So E2 is equal to minus your D phi 2 1 divided by dt. So which is equal to, I'm going to substitute the relation phi 2 1 substitute minus d by dt of your M into I1. So M on the constant type. So minus M into di1 by dt. This is your E2. Okay, remember this relation. அதே வந்து secondary to primary வரும்போது இங்க E1 வரும், இங்க current வந்து I2 வரும். அவ்வளவுதான் difference. Now in this case, suppose if current I is equal to 1 amp. Current I is equal to 1 amp. Appo flux phi to 1 enago, it is directly proportional to your mutual inductance. And as well as the same thing, if your di by dt, current di1 by dt, இது 1 amp இருந்தா, அப்போ EMF என்னாகும், it will be your mutual inductance M. Okay. So these are your small cases. Please take it. Or not?
Or sir.
Okay. Okay. So next one. Next one. So here we are going to discuss about the relations in terms of your mutual inductance and as well as your permeability. The relations. Let's see. So make a heading: mutual inductance of two long coaxial solenoids. Mutual inductance of two long coaxial solenoids. Let's see. So what I'll do, I'll take two solenoids. Two solenoids, those are mutually connected with each other. Let's see. So I'll take this one as primary coil, and I'll take the length of the conductor, length of the coil as L. Yes, ma'am. What happened?
Video stuck.
Video stuck ஆயிடுச்சா?
இப்போ வந்துருச்சு.
Some delay will be there, network issues. Okay, right, ma'am. So we'll continue. So இதுல வந்து நான் என்ன பண்றேன், ரெண்டு coil எடுத்துக்கிறேன். These two are mutually connected with each other. So I'll take this one as primary coil. இதோட length வந்து I'll take as L. So number of turns வந்து I'll take as N. And I'm connecting secondary. So this is your secondary coil. These two are mutually connected with each other. So primary coil வந்து what I'll do, I'll connect a voltage. Secondary coil என்ன பண்றேன், I'm connecting a galvanometer, where current flow ஆயிட்டு இருக்கா இல்லையா நம்ம check பண்றதுக்கு யூஸ் பண்ணுறோம். Okay. So this is your secondary coil. These two are mutually connected with each other. Now let's see the relations. So when you're discussing about the primary coil, so primary coil நான் என்ன பண்றேன், current flow பண்றேன். When I'm allowing the current passing through it, what will happen, இது வந்து flux வந்து induce ஆயிட்டு இருக்கு to the secondary coil. So this flux is linked to the secondary coil. Because of the flux linked to the secondary coil, or EMF வந்து induce ஆகும். Because of the EMF induced, what will happen, the current is flowing through the circuit in the secondary, and the galvanometer will try to deflect here. எல்லாமே okay. But இங்கே mutual magnetic field, what are the magnetic field we are discussing here? This magnetic field I'll take as B1, and இதோட secondary வந்து I'll take the magnetic field as B2. Let's say from the solenoid, ampere circuit again. Magnetic field due to the primary solenoid. Magnetic field due to primary solenoid. Primary solenoid. Magnetic field due to primary solenoid. So that means B1 is equal to, it is a mu naught N1I. B1 is equal to your mu naught N1I. And on the number of turns, so I'll take it as N1. Number of turns per unit length, I'll take it as small n1. Small n is N1 is equal to, so capital N1 divided by your length of the conductor N. Okay. So number of turns, so then I N1 current on the I1. Okay, so இது வந்து magnetic field வந்து ஒரு create பண்ணிட்டு, and this magnetic field is linked to your secondary. So I'll take the relation as flux linkage, flux linked across, flux linked across 1 ton of the secondary coil. So here we'll discuss about the 1 ton of secondary coil. So when we discuss about the 1 ton, so இங்க வந்து என்ன பண்ணிட்டு இருக்கோம்னா, so flux phi 2 is linking with respect to 1. So phi to 1 per ton is equal to, the relation is B1 magnetic field தான் இது வந்து secondary coil க்கு link ஆயிருக்கு into its area A. So which is equal to B1 is nothing but your mu naught N1 I1 into area A. Okay, N1 I1 into area A. Or I can rewrite the relation as small n1 is equal to capital N1 divided by, so mu naught capital N1 divided by your L into I1. Remember this one. This is your flux phi 21. Okay, per ton. அதே வந்து total number of turns across the second. Total number of turns. Total number of turns across secondary. Total number of turns across the secondary. So across the secondary and சொல்லும்போது I'll take the relation. So 5 to 1. So total number of turns is equal to, it is mu naught your N1 by L into I1 into A into the number of turns in secondary. So that is, I'll take it as N2. So which is equal to mu naught N1 N2 I1 A divided by L. Or I can rewrite the relation where small n1 is the number of turns per unit. I can rewrite the relation as mu naught N1 N2 I1 into A. Okay, so these are your relations for your flux. So we got the flux. So now I'm going to compare. Okay, comparison எப்படி பண்றேன்னா, so flux phi is equal to m into your I and சொல்லிட்டு நம்ம already discuss பண்ணிருக்கோம் in later last class. Okay, last topic. So m into I. So from this relation, what I'll do, I'll going to compare this relation. I'll take this one as first one. I'll take this one as the second one. Now இது ரெண்டும் வந்து compare பண்ணேன். When I do compare these relations, so from this we can take m is equal to, remember m is equal to your mu naught n1 n2 a by L. Mu naught n1 n2 a by L, or m is equal to mu naught small n1 small n2 a by L. This is your mutual inductance. Okay, remove it. Either a unit of the as usual, it is nothing but your hint. And if you see that now the primary and the secondary connect pannalam, secondary and the primary connect pannalam, but either a mutual induction the constant இருக்கும், it will be the same. So இப்போ நம்ம டிஸ்கஸ் பண்றது primary towards the secondary. Same thing when we discuss about the secondary towards the primary சொல்லும்போது அதோட flux எப்படி இருக்குன்னா இது வந்து 512 இருக்கும். Here நம்ம இப்போ டிஸ்கஸ் பண்ணது 521. So 512 521. அப்போ mutual inductance ரெண்டு சேமா இருக்கும். So I'll take the relation M12 is equal to M21 is equal to M. Remember it. Primary in the secondary, secondary in the primary. Mutual inductance. Please take it.
Okay. Sir, the notes are copy பண்ணியாச்சு.
Yeah, so this itself enough. So நாளைக்கு கிளாஸ்ல வந்து we'll do some problems on this case. Okay.
Okay. சார் இந்த ஆர்எல்சி சர்க்யூட் டாபிக் இருக்கு சார் இந்த சாப்டர்ல.
எதுமா
ஆர்எல்சி
RLC சர்க்யூட் இதுல வராதுமா. இதுல வரும் ஆல்டர்னேட்டிவ் கரண்ட் நெக்ஸ்ட் சாப்டர்ல வரும். இதுல வராது. இதுல only இண்டக்டன்ஸ் சீரிஸ் கனெக்ஷன் parallel கனெக்ஷன் நம்ம நெக்ஸ்ட் கிளாஸ்ல பார்க்கலாம். ஓகே, அது ஒரு ரிலேஷன் மட்டும் தான் இருக்கும். ஸோ நம்ம டெரிவேஷன்ஸ் எல்லாம் வேண்டாம். ஸோ சீரியஸ்ல இருக்கும்போது எப்படி லைக் சிமிலர் டு யுவர் கெப்பாசிட்டர், சிமிலர் டு யுவர் ரெசிஸ்டர், சேம் திங். ஓகே, ஸோ திஸ் இட் செல்ஃப் நீங்க வந்து ப்ராக்டிஸ் பண்ணுங்க. நாளைக்கு வந்து we are going to do some problems on these cases. ஓகே, அண்ட் உங்களுக்கு டெஸ்ட் இருக்கும். ஆஃப்டர் அவர் 4 o'clock கிளாஸ் யூ வில் பி ஹேவிங் யுவர் டெஸ்ட். ஓகே, அப்போதான் நான் வந்து கொஸ்டின் பேப்பர் ஷேர் பண்றேன். ஓகே, ரைட். செல்சி ஈவினிங்
2:30 லிங்க் அனுப்புறீங்க.
நான் 2:30 நான் லிங்க் அனுப்புறேன். நீங்க வந்து குரூப்ல நான் ஆட் பண்றேன் உங்களை எல்லாம். ஸோ அங்கே நான் வந்து ஷேர் பண்ணிடுறேன் லிங்க். ஜஸ்ட் ஜாயின். ஓகேவா
சார் அப்புறம் மெட்டீரியல் தரேன்னு சொல்றீங்க. என்ன
நான் மெட்டீரியல் வந்து இந்த பிடிஎஃப் வந்து எதுக்கு இப்போ நம்ம நாளைக்கு முடிச்சிட்டு கொடுப்போம்.
சரி, ஓகே.
டெஸ்ட் அட்டென்ட் பண்ணுங்க. நீங்க இந்த மெட்டீரியல் முதல்ல அந்த சாப்டர் வந்து நீங்க அட்டென்ட் பண்ணுங்க. ஐ டோல்ட் யூ ஆல்ரெடி நாளைக்கு நான் क्वेश्चंस கேட்கறேன்னு சொல்லிருக்கேன். ஸோ வாட் ஆர் தி டாபிக்ஸ் வி கம்ப்ளீட்டட் டில் நவ. ஓகே, அது ஒரு தடவை வந்து கோ த்ரூ பண்ணுங்க. ரைட் பண்ணு. ஓகே, we'll see you next class. Bye.